All right. Well, hello, Honors Algebra 2. A little bit different scenario we're in right now. I'm going to try to keep things as normal as possible for you, though. This will be the first video out of 3 that'll be posted this week. This one's going to be on the Intro to Trigonometry. You'll have another one that'll be posted referencing coterminal angles, solving triangles, and then unit circle investigation. So basically this right here is kind of what we're looking at for this week. So that being said, let's get into things. And again, with these videos, to make them a little bit shorter, what you're going to find is that any definitions that are in the notes I have already written in there for you. That way, if you need to, feel free to pause the video, but that way the video doesn't take like 20 or 30 or 40 minutes just because I'm sitting here trying to write definitions down for you. But we do need to start with some definitions. So intro to trigonometry. First definition we're going to start with is an angle. So the definition of an angle is a set of points consisting of 2 different rays that have the same endpoint. Visually what that looks like, I'm sure you're familiar with what an angle looks like. Keep in mind a ray is a point and then at half of a line extending in one direction. So an angle is just 2 of those. So it's 2 rays, common endpoint. Now we do have some special types of angles. In fact, we've got what's called the standard position of an angle. So that is an angle in a coordinate plane such that its vertex is at the origin and the initial side lies on the positive x-axis. So to give you an example of what that looks like, the first part of this says that it has to lie in a coordinate plane. When we talk about coordinate plane, we're talking about an xy plane, or a grid is essentially what we're looking at, or a graph. So what it looks like for an angle to be in standard position is you've got what's called the initial side, which the initial side is the starting side. It's where the angle starts. Has to be on the positive x-axis. So this is the initial side of the angle. Then your terminal side can be pretty much anywhere you want it to be. So maybe your terminal side is all the way over here. Now there's going to be 2 different ways that you can measure that angle. The first way is what's called a positive direction, meaning you're going to measure the angle starting from your initial side and going in a counterclockwise rotation to its terminal side. So this would be a positive angle measure. You can also have a negative angle measure, which is again measuring the angle, but instead of going counterclockwise, you actually go clockwise. Which is actually the next couple of definitions, if you hadn't already copied those down, is the difference between positive angles and negative angles. So a positive angle is an angle measured counterclockwise in standard position, and then a negative angle is an angle measured clockwise from standard position. All right, 2 more definitions before we look at some examples. The next definition, degree measure of an angle, is the portion of one full rotation that's expressed as 1/360th of the entire circle. That's the one that you're probably familiar with when you're talking about 30 degrees or 45 degrees or 90 degrees. The second one's a little bit different. It has to do with what we talked about before spring break, if you can remember all the way back to when we did our Twizzlers activity. We've talked about what's called the radians of a circle, or the radian measure of an angle. So for a circle with radius r, the measure of an angle in standard position whose terminal side intercepts an arc of length r is 1 radian. So as a reminder, what we did there to help you visualize that, we took our Twizzlers, we measured out 1 radius, and then we took that 1 radius and we traced it around the circle. So that's essentially the same idea here, just using that to actually measure angles rather than just measuring the distance around the circle. Okay, so to do some practice, let's go ahead and start some sketches. So sketch each angle in standard position. And you're going to notice that I'm not going to use a protractor for any of these, and really, again, we're just sketching it, so it's not all that important. It is going to be important, though, to show a couple different things. For example, on A, when you're talking about a 45-degree angle, let's just go ahead and label our what are called quadrantal angles. So you start at 0 degrees. When you get to here, that's a 90-degree angle because that would be a right angle. If you go another 90 degrees, that's 180. Another 80 degrees is 270. And if you come all the way back around, you can go up to 360. You can actually keep going, and in fact, we're going to see an example of that in a little bit. So when we want to sketch a 45-degree angle, a couple things that I'm going to want you to show me. The first is I'm going to want to see that you graphed your initial side on the positive x-axis. I'm doing that in blue. The second thing is for 45 degrees, you can actually be pretty accurate with this one because 45 would be exactly halfway between 0 and 90, so your angle needs to be exactly halfway in between 0 and 90. The other thing I want you to show me that's going to be new that you maybe have not done before is you need to show me the direction of the angle. Since this is a positive 45-degree angle, we're going to draw the direction of the angle like so. Okay, let's do another one. So now we're going to look at a 225-degree angle. So again, I'm just going to label what are called the quadrantal angles, or these ones that go around by 90 degrees. And again, we'll start it kind of the same way. We'll start with our initial side on this positive x-axis. And 225 we can actually be pretty accurate with as well. 225 degrees actually lands halfway in between 180 and 270 degrees. And the only other thing you've got to do then is show the direction of that angle. Okay, I think we've got a couple more to look at. So for C, we actually get our first example of a negative angle. We're going to start it kind of the same way, but the difference is rather than going to 90 degrees up here, we're actually going to go clockwise since we're measuring it in a negative direction. And instead of being a positive 90 degrees, it's going to be negative 90 degrees. Then the rest are going to continue kind of the same way. So instead of being a positive 180 degrees, that would be negative 180, and then negative 270, all the way around to negative 360 degrees. Okay, so now to sketch our angle. Again, we're going to start it kind of the same way. We'll start with our first ray on the positive x-axis. And then to measure it, this one again should be pretty easy to get a pretty accurate sketch of, because negative 135 would actually be halfway between negative 90 and negative 180. And again, here you've got to be careful because you're measuring it in negative direction. You have to draw your measurement in a clockwise rotation. So don't go counterclockwise on this one. All right, one more to show you here. And this one's going to be a little bit different because now if you notice, we're going to have to go past 360 degrees. So I'm going to go ahead and put our labels in here. And you don't need to do this every time, but I think it does help you to be a little bit more accurate. And then to graph 360 degrees, or 370 degrees, that would mean that you went all the way around one full rotation. And then if you think about it, then you'd have to go another 10 degrees to get to 370. And so here would be your angle. Okay, cool. So example 2, determine the quadrant in which the terminal side of the angle lies. So now we don't even have to graph it, we just have to think about where it ends up. Now just as a reminder with your quadrants, because I'm sure it's been a little while, let me go back up to number 1A and let's label our quadrants. Your first quadrant is this top right quadrant. And then the quadrants actually follow in the same order that the angles do. So if you think about going counterclockwise, that would make this quadrant 2, this quadrant 3, and this quadrant 4. Notice that when I write those, I use Roman numerals to say that it's a quadrant, and I'd like for you to do the same. Which maybe that makes sense now why the quadrants are labeled like they are. I don't know if you had thought about that before, but now that we're talking about them in the context of angles, I think it makes a little bit more sense why we would choose to go in that order. So if you think about where 210 degrees would be, 210 degrees would have to be somewhere between 180 degrees and 210 degrees, or 270 degrees, so that would mean that this angle would have to be somewhere in quadrant 3. For 2B, I would look back at 1C where we labeled our negative quadrants, and so again the quadrants stay the same. So even though on example C we were graphing it in a slightly different order, the quadrants are still the same. So negative 120 degrees would have to be somewhere between negative 90 and negative 180. That would also have to be in quadrant 3. I think C is pretty easy, 30 degrees, that means you have to be in quadrant 1. And then for D, think about 390 degrees. It's very similar to example D where we did 370 degrees. That would be one full rotation plus another 30 degrees. So that would really kind of be the same as a 30-degree angle. That would also be quadrant 1. Okay. Moving on to example 3. So in example 3, it asks us to label each of the following circles in terms of both degrees and radians. This is going to take some time, so feel free to pause the video as we work through this. Let's start with our first circle here. And let's think degrees first, since degrees are a little bit easier maybe to work with. So obviously you've got from 0 and 360 degrees. We have a pretty clear one over here is 180. And I think you could probably agree that this is 90 and this is 270, kind of like what we were doing before. So then what you really want to think about is, how are you dividing up your circle? If you are dividing into 3 sections between 0 and 90 degrees, then take 90 degrees, divide by 3. That means that you're going up by 30 degrees each time. So this would be 30 degrees, add another 30, would be 60 degrees, add another 30, and we get to 90. And then if you continue to add by 30 degrees, what you'll find is that the other angles kind of fall into line. So 180, 210, 240, 270, 300, and 330. And make sure that you're drawing in those degree symbols all the way throughout. Let's do this. Let's go and do the other 2 circles in degrees, and then we can come back and talk about radians. So the next circle, we'll do kind of the same thing. Let's start with the ones that are clear right off the bat. So that's 0 and 360, 180. Once again, you've got 90 and 270. Instead of dividing it into 3 sections, though, this time we've got it divided into 2. So now take 90 degrees, divide by 2. Tells you that now you're going to be going up by 45 degrees each time. So 45 degrees here, plus another 45 is 90, plus another 45 is 135 degrees, plus another 45 is 180, plus another 45 degrees is 225, plus another 45 is 270, and then 315 and 360 degrees to finish it off. Okay, one more to go here. So again, we can start by labeling the ones that are kind of clear off the bat. So 0 and 360, 180. But notice this time you cannot label 90 and 270. They're not on the circle for us. So instead, let's think about how we're dividing up 180. And it looks like we've got 1, 2, 3 sections that we're dividing that 180 degrees by. So take 180, divide by 3 is 60. So now we're going up by 60 degrees each time. So 60 plus another one, or 60 is 120, plus another 60, 180, and then 240 and 300. Okay, so that gets us all the way through labeling those in degrees. It also wanted us to label these in terms of radians. And radians work a little bit differently, but kind of the same. So when we talk about radians, something we figured out from our Twizzler activity is to get all the way around the circle, it took a little bit more than 6. In fact, it took us 2 pi radians to get through one full rotation. So if you think about what half of that would be, so like for 360 degrees, half of that's 180. For radians, 2 pi, half of that would have to be 1 pi. And so then from there, we can start to divide this up kind of the same way. So let's think about now we've still got 1, 2, 3 sections, but now to get to pi, we actually have to divide that up by 6. So what we'll do, kind of similar to what we did with degrees, is we'll take our full measure, which was pi, and we'll divide that by 6. And then we'll just leave that as a fraction, actually. We won't even have to simplify it. So this first angle would have to be pi over 6. So pi over 6 would be the same as 30 degrees. If I add another pi over 6, 1 pi over 6 plus 1 pi over 6 would be 2 pi over 6. So 60 degrees would be the same as 2 pi over 6. And you could reduce that if you wanted to. I'm just going to leave it as 2 pi over 6 for now. So if you add another pi over 6, you get 3 pi over 6. So 90 degrees would be the same as 3 pi over 6. Or again, if you want to reduce it and write pi over 2, that would be okay. So really, if you think about it, it's going to be pretty easy to count around by radians. You just keep going up by pi over 6. So this would be 4 pi over 6. At 150 degrees, that would be 5 pi over 6. At 180 degrees, that would be 6 pi over 6. And then you just keep counting your way around. So 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. And when you get back to 2 pi, if you think about it, you'd be at 12 pi over 6, and 12 over 6 is 2. Okay, let's do that again. So let's look at our next circle. And again, remember the full rotation would have to be 2 pi. Half of that would be 1 pi. And again, we're going to break that up into some sections. This time we're going to break that up into a total of 4 sections. So now instead of taking pi and dividing by 6, we're going to take pi and divide by 4. So that would be 1 pi over 4, 2 pi over 4, 3 pi over 4. At 180 degrees, that would be 4 pi over 4. And then 5 pi over 4, 6 pi over 4, 7 pi over 4. And then when you get all the way back around, 8 pi over 4. If you think about it, 8 over 4 would be 2. Okay, we've got one more to go. So our last circle that we've got here. Again, we'll start by labeling the 2 that we've always labeled, which is 0 and 2 pi. And then at 180 degrees, that's just 1 pi. And this one, we're actually going to divide up the same way we did before. So there's still going to be those 1, 2, 3 total sections. So we'll take pi and divide by 3. And then we'll continue to add by pi over 3's all the way around. So 60 degrees would be the same as pi over 3. 120 degrees would be the same as 2 pi over 3. 180 degrees would be 3 pi over 3. 240 would be then 4 pi over 3. And then at 300 would be 5 pi over 3. And again, at our 2 pi, that's the same as 6 pi over 3. Okay, so now that we've got kind of 2 different ways to measure angles, it would be kind of nice to have a way to go back and forth between the two. So it'd be nice if we had some formulas that could convert between radian and degree form. That's what we'll talk about next. So if we want to convert from degrees to radians, we kind of want to pick some nice places out, some nice angles to try to remember. Like, to me, I don't know about you, but it would be kind of hard to try to use 11 pi over 6 and 330 degrees as a way of converting. So I would probably not choose to use that one. I would try to pick ones that we use consistently. That would mean let's either use, well, we could try to use 0 and 0, but that's really not going to do anything for you. But the 2 pi and 360 would be kind of easy to remember. If you think about it, a circle always is 2 pi, always is 360. That's a pretty easy one to remember. So let's use that for right now, and then we'll see if there's something else we'd rather use. So if we want to go from degrees to radians, what we're going to do is we're going to multiply our degrees by 2 pi over 360 degrees. That way the degrees will cancel when we're doing our conversion. But if you think about it, looking at 2 pi over 360, while that might be one that's easy to remember, it's really not simplified. Really, the simplified thing to do would be to divide by 2, and 2 pi divided by 2 would just be pi. 360 divided by 2 would be 180 degrees. This is probably the more simple way of writing it. In fact, that's going to be the conversion factor that we're going to use. And it really is just about as easy to remember. If we want to go the other direction, so if we want to convert from radians to degrees, we're still going to multiply, but now we're going to multiply our radians by 180 degrees over pi. That way, in most cases, you'll end up with pi that cancels out. Okay, so example 4. Find the exact radian measure of each angle given in degrees. Give all of your answers in terms of pi. So, again, to convert from degrees to radians, we're going to multiply by pi over 180. So for 30 degrees, multiply by pi divided by 180 degrees. And if you're doing it right, what you'll end up with is the degrees will cancel, and you get 30 pi over 180. Now, if you notice, that can be simplified. 30 divided by 30 is 1. 180 divided by 30 is 6. So the simplified way to write your answer would just be pi over 6. In other words, 30 degrees is the same as pi over 6. If you want a way to check yourself, we actually did that one before, because we said that 30 degrees was the same as pi over 6. Okay, let's take a look at another one. Let's take a look at 90 degrees. So let's do it the same way. We'll take 90 degrees, multiply by pi over 180 degrees. Again, degrees will cancel. You get 90 pi over 180. But again, you're going to notice something's going to simplify. Both are divisible by 90. 90 divided by 90 is 1. 180 divided by 90 is 2. In other words, 90 degrees is the same as pi over 2. Okay. For C, we just have a negative angle measure here, but we'll do the exact same procedure. So negative 135 degrees multiplied by pi over 180 degrees. Again, degrees will cancel. And that's an easy way to check yourself too as you're working through these. So then you end up with negative 135 pi over 180. This one you might have to simplify in a couple of steps. Turns out the largest thing you can divide each of those by is 45, excuse me. And so if you take negative 135 divided by 45, that ends up being 3. 180 divided by 45 is 4. So your simplified answer would be negative 3 pi over 4. Okay, one more going this direction. So 260 degrees multiplied by pi over 180 degrees. Again, degrees will cancel. You get 260 pi over 180. And then for this one, the largest thing you can divide those both by is 20. If you take 260 divided by 20 is 13. 180 divided by 20 is 9. And your simplified answer is 13 pi over 9. Okay, cool. So next, find the degree measure of each angle. It says if necessary, we're going to round to the nearest tenth. So when we start off with, let's take pi over 3, and we're going to convert from radians to degrees, which means now we're going to multiply the number of radians by 180 over pi. Now, an easy way to know if you're multiplying by the right thing or not is that something should cancel. So if you did something like this and made a mistake, which can happen, what you're going to find is that when you try to take pi multiplied by pi, they're not going to cancel like this. And so that's a good way to know that you wrote it in the wrong direction. So instead of pi over 180 degrees, 180 degrees over pi, that way your pi's will cancel. So then you've just got 180 degrees over 3. So take 180 divided by 3 is 60 degrees, and there's your answer. This is another one that we could check ourselves with. We actually did this one up above. We said that 60 degrees was the same as pi over 3. Okay. So for B, negative 5 pi over 3, let's go ahead and convert that to degrees. So we're going to multiply by 180 degrees over pi. So the pi's are going to cancel. Take negative 5 multiplied by 180 is negative 900 degrees divided by 3. And when you divide that, you end up with negative 300 degrees. Okay, let's move on to C. So now we've got 6 radians. And notice it doesn't say 6 pi radians. It just says 6 radians. So we're going to have to be a little bit more careful with how we work through this problem. We're still going to multiply by the same thing. So we're still going to multiply by 180 degrees over pi. But notice that this time nothing's going to cancel. If you take 6 multiplied by 180, you end up with 1080 degrees over pi. And then to simplify that, now is where this part where it says round to the nearest tenth of a degree comes in. Here's where you need to be very careful. You need to use the pi button on your calculator or online, but do not type in 1080 divided by 3.14. 3.14 does not equal pi. Make sure you're using the pi button. Your answer to the nearest tenth of a degree should end up being 343.8 degrees. And so you round up that tenth to 0.8. If you did try to take 1080 divided by 3.14, what you're going to end up with is something that's close but not the same. You would have actually ended up with 343.9 degrees. Now it's not off by much, but a tenth of a degree is enough to count you wrong on big ideas and count you wrong on a quiz if you choose to take it at the end of the week. We're going to skip D. D is pretty much the same thing. Set it up the same way as you did C. And I'll kind of leave that up to you guys to work through on your own. Okay. One more part to this section, and then we'll be done with this first section of notes. So for example 6, it asks us to determine the quadrant in which the terminal side of the angle lies, and then sketch the angle in standard form. You'll notice that this is similar to what we did back on example number 1, was we sketched each angle in standard position. The only difference is now we're going to sketch them in degrees, so a little bit different. So when we sketch these in degrees, we're going to use slightly different labels. And I would choose to use the labels that match your denominator. So when you think about 90 degrees and that being, well, pi over 2, that would be the same as 2 pi over 4. And then the same at pi, if you think about what that would be the same as 4 pi over 4. And then at 3 pi over 2, which would be what 270 degrees is the same as, that would be the same as 6 pi over 4. So when you're sketching this angle in standard form, 1 pi over 4 would be halfway in between 0 and 2 pi over 4, and that would be this angle right here. Okay, so for example B, we're going to look at negative 2 pi over 3. The same way that we would for degrees and going around clockwise, we'll do the same thing here. So we start at 0 and, well, I should be more careful. This should have been 0 and negative 2 pi. Then we've got negative pi over 2, negative pi, and negative 3 pi over 2. So those are kind of your quadrantal angles for radians. 0, pi over 2, pi, 3 pi over 2. So the problem with this is that you would want to write everything with a denominator of 3. But the problem is some of them already have denominators of 2. And you can't get a 2 to be a 3 without using decimals. So instead, let's think about what a common denominator would be. So with 2 and 3, common denominator would be 6. So let's do this. Let's just write everything as fractions over 6. So this would be negative 4 pi over 6, the angle we're looking to sketch. This would be negative 3 pi over 6 here. This would be negative 6 pi over 6. And this would be negative 9 pi over 6. And then we can think about where negative 4 pi over 6 would be in relation to those. It would be past negative 3 pi over 6 and about a third of the way to negative 6 pi over 6. And then again, remember you're measuring a negative angle, so you'll have to draw your angle in like so. Okay. For C, actually, you can probably do that one on your own. Just reuse those same labels that we did before. So 0, negative 2 pi, negative 3 pi over 6, negative 6 pi over 6, and negative 9 pi over 6. Think about where negative 1 pi over 6 would be, and then you'll have your answer. So let's do D, and this will be our last one for this section of the notes. So with 5 radians, and this one we can actually probably think about in this way, is to go all the way around the circle. That's about 2 pi radians. So as a decimal, it's 6.28 and so on radians. So halfway around would be pi radians, so 3.14 and some change radians. And so then if you think about what would be halfway in between those numbers, probably the easiest way is to add them up, divide by 2. That would be 4.71 radians here. 5 radians is just a little bit past that. And again, we're measuring it in a positive direction, so we'll go around counterclockwise like so. All right, I know this section of notes was a little bit longer. It did kind of take a little bit more because it was kind of the basics of what we were going to be talking about in the upcoming units and upcoming sections. So our next video, we'll talk about reference and coterminal angles, what they are, where they get used. I will see you then.